Hello everyone, and welcome back. In this video, we're going to be making some repairs to Brutus. I'll show you some of the machining that was done to make those parts or repair those parts. And then we're going to take it out for a test ride. If there's anything you see in these videos you like, please give a thumbs up. If you have any other suggestions for another video in the future, please let me know down in the comments.
So here are some of the components we need to repair. First were these chain slack adjusters. The sprocket had a bronze bushing in it, and then it rode on this shaft, and there's a lot of slop in there. These things are in pretty poor shape. Really, if I could find some new ones, I probably would. But what I'm going to do, because if you can see on this shaft here, it's worn bad. I think the chain jumped the sprocket and just ran into this shaft. So I'm going to cut this off, and then I'm going to, on the lathe, make a new one out of this piece of steel here. And we're going to drill a hole through it, press it back in there, and weld along the back. And then when we have to put this hole in for the cotter pin. So we need to do that on both of them. These were a little bent up. I did straighten them off camera a little bit. They also have this hardened bushing in here, which I will put back in again. And then these sprockets had grease fittings in which were worn so bad they're not even usable. And this one looks like it worn down on the collar edge here and cut into where the grease zerk was. So I'm not sure what I'm going to do with that yet. I may make a spacer in here and weld it back onto that and retap this hole. And this hole is kind of stripped out too, so that's going to require some attention. And then onto these. If you watched the previous video on this, you see how this is broken out here. There should be a roller bearing, like a caged roller bearing inside of here. And this one was completely gone. I could not find a bearing like that yet. So what I'm going to do to patch this thing along, I'm going to, on a lathe, I'm going to create a steel bushing that fits down inside of here. In fact, I'll probably have to bore this out to true it up again, press in a bushing. Then I have this old, this is from an old die, a bushing here. I'm going to machine off this surface and probably shorten it up just a little bit, and then press that inside of the bushing that I'm going to press in here. So we're going to have like a bushing within a bushing. I know it's not a roller bearing, but I think that's going to get us by for this year, because the shaft it's going to on the hub, you probably can't see that from here, but that's kind of worn out and really needs to be reworked as well. So if this happens to wear into that shaft, that's fine, because that's going to get replaced. But this should get us by for this year. So I'll show you some of the machining I did to rebuild these parts. So we're going to take the hacksaw and try and saw these off. I don't know how hard they are. Hopefully it can do it. So after the studs were sawed off on both the brackets, I took them over to the mill and machined them flat again in preparation to have them drilled back out. Here I'm center drilling the old stud. This is just a rigid short drill to get the drill bit started straight. going to use a chamfering tool here. Basically this just breaks the sharp edge off the hole so you don't cut your fingers. Now we need to make some new shafts for the sprockets, and these will get welded into the arms. And then we're going to come back eventually and drill some holes through them to allow the cotter pins to hold the sprocket on. We've got the diameter turned down to 0.625 inches or 5/8 of an inch. So that's where we need them for the sprockets to fit over. So here's where we are with the brackets. We have the old stud here drilled out, or I actually cut it off with a hacksaw first, drilled it out in the milling machine. Then we have the new stud created. And this is 5/8 inch diameter here. I turned it down to a 1/2 inch diameter. And we're going to be able to press that in there. We're going to go over to the welder. Once that's pressed in, we're going to just weld a TIG weld, a bead around here to hold that in. But before I mount this in there, we have to drill a hole through. There's a hole in here for the cotter pin, and that holds on the sprocket, just to keep them sliding off. And I don't think there was a washer on here, but we'll have to see if one is necessary there. So now we're going to go and drill these holes through. We're going to set this back up in the milling machine. I have two narrow parallels put together there. We're going to set it on like that. And we're going to reference off the edge of these vice jaws. So I'm going to snug it up here. Back it off a little. I'm just going to put this block here. I'm going to push it up against that block. And then we're going to tighten it down. I'm going to slide back these parallels so when we drill a hole through, we don't run into them. So we're going to go through with our center finder or edge finder. We're going to pick the center of these vice jaws back up again. We're going to come over and touch off on the edge of this post here, and to reference to the center line of the edge there. This tool here can go by several different names: an edge finder, a center finder, or a wiggler. Without getting into a long explanation of it, it basically accurately finds the edge of a part or finds the center line of something. So right now I'm picking up the center line of this shaft we're going to drill a hole through, and then I'm going to come back and find the edge of it, and then we can be accurately located. I'm now moving over to pick up the edge of the shaft so we can locate our hole. So I'm going to drop the center drill in, and we need to move 3/8 of an inch over and locate our cotter pin hole. So 3/8 of an inch is 0.375 in decimal. The center drill is in the drill chuck, and right now we're just creating like a pilot hole to start the drill so it starts accurately. So we're going to be drilling through with a 9/64 inch bit. That's 1 fractional size over from an 1/8 inch. Okay guys, just made a mistake. That's not supposed to be over 3/8 of an inch. That's supposed to be less than that. Okay, that should not have been 3/8, that should have been 3/16. So, not terribly critical for what it is, but we're going to move it over and drop it in where it should be. Now I'm recenter drilling the hole, then I'm going to put the drill bit in, and then we're going to drill that hole once again, and then we're going to go ahead and put the other shaft in and drill that hole in as well for the cotter pin. There, it looks fine from this side, just not from there. Okay, that completes putting the hole through these. Now I'm going to take a little die grinder and just run around the edge of these holes to take the sharp edge and burr off of them. And then we're going to run over to the welder and weld them in after I press them in. The shafts are now pressed into the arms, and then I sandblasted them because we're going to TIG weld them, and TIG welding them requires that to be quite clean, so I just hit them with a sandblaster a little bit. Now we're going to have to walk over to another building where the TIG welder is and weld them up. It's a really old TIG welder, so I'll explain that a little bit too. We're coming up to the old Lincoln Ideal Arc TIG welder. It's also an arc welder with straight and reverse polarity. I opened up the side panel on this welder one time, and I believe I found a date built in 1974. I've owned this for almost 20 years. I bought it used at an auction of a machine shop going out of business, and I got to give hats off to the engineers who designed and those who built this welder. It has performed flawless for me, and it's not in the best environment. It's humid in the summertime and cold in the winter, and if you look inside this thing, it's just stacked full of old circuit boards, and it's just reliable as can be. So we're gonna weld up these shafts to the arms and see how that goes. This welder has a foot control. It's kind of like a throttle pedal. It'll control the amperage as you're welding, so you can fine-tune your weld as you go along. The welding head, or the welding torch on this one, is liquid cooled, so there's coolant lines running to it to cool it. If you're going to weld a lot, you want to have that cooler running. And so I'm putting in a piece of tungsten. I had ground it to a sharp point, and I'm going to tighten that up. Going to clamp it in the old vise. I believe this vise is really old as well. I picked this up at an auction probably about 30 years ago. I want to say maybe there was a date on it, patent date, but I don't recall. I'd have to look at it again. What I'm doing here is I'm going to put a piece of plywood in front of the cooling fan on the welder. What tends to happen, this is like a shielded gas type of welding, and that fan will tend to blow onto my weld and distort or screw up the flow of the gas. So, because I'm sitting so close to the welder. So I usually just block it off with a board, and that helps the weld out. I believe I have the settings set where they need to go already. We're going to be using the remote control for the foot pedal, and we're going to have the cooler turned on. That's actually plugged into one of those 110 outlets on the front. Okay, that's a little crude for TIG welding. The filler rod I was using was really way too big for what I was trying to do, but nonetheless, it worked out okay. So now we have to deal with these idler sprockets. They're in pretty rough shape. The grease fitting, I thought these were a thread-in type, but looking further into it, these appear to be a pressed-in type. So I was able to get those knocked back out, but this one's worn so bad you can see it ran right through it. You know, they should probably just be scrapped. I did find, well, I found an entirely new arm assembly with these and the arm. They were about $110 a piece, so that'd be times 2. So I'm not going to do that. I did find where you can buy sprockets. They're 9-tooth, very similar to this. They had a little smaller bore, and you could get them in either a keyway or set screws. I think they were about $20 at MasterCar. I could go that route, although they'd still need to be modified. I'd still have to bore them out to accept a bronze bushing, and would still have to fit in a grease fitting somehow. Maybe that could be pressed into where the set screw is. I don't know. But what we're going to do is we're going to salvage these things. I've got a scrap piece of steel here. Actually, this is part of a PTO shaft from a tractor. I'm going to turn down this end to fit the diameter of these, or just slightly bigger. When I measured these, they came out to be just maybe 1/1000 over 3/4 inch. So I'm going to make them, I'm going to call this an arbor. We're going to turn this back 1/2 inch, and then we're going to make it 0.752 of an inch. And then we're going to heat these up somehow. Either I'm going to take a propane torch or a electric it's actually a crock pot heating device. And then we're going to just tap that on there. Hopefully it'll expand enough to just slide right on there. And then I'm going to kind of true this up a little bit, and true this edge up a little bit. And I'm going to cut a little recessed area in here on both of them. I'm going to come back and create a little sleeve that will attach onto there. and widen this back out to where it should be. And I don't know, probably tack weld that on with a TIG welder just a little bit. So, and then not sure what to do about this yet. I could just come to the other side and poke a new hole in. Maybe just fill that in with some kind of filler, JB weld maybe. It's nothing structural. So, yeah, so here we go. I'm going to mount this round stock back into the 4-jaw chuck on the lathe. We need to turn it down to about 3/4 of an inch to accommodate the sprocket, and we're going to press that on and do the work we need to do on that. We're going to speed through the process of indicating this in the 4-jaw chuck. We're going to set up the dial indicator here, and we're just going to go through it quickly because it takes a little bit of time and it's not real exciting. Okay, so we're well within 1/1000th of an inch here, and really it doesn't matter because I'm going to be truing this up anyhow, so it just makes it a little bit easier if I ever had to come back and set this up again. The camera wasn't recording here when I turned down this end of the arbor, but it is now at about 0.752 inches, which should give us about a 1/1000th press fit when we go to press on the sprocket. So we're going to heat that up now and press it onto our new arbor. We're going to heat the sprocket up to somewhere around 300 degrees. I think that would be enough to expand it far enough for what we need to do. So I just have the little propane torch, putting some heat to it. I'm going to check it with a digital laser temperature tester. So depending on where you're at, it's around 300 degrees. So that should be sufficient. Getting ready to press it onto the arbor that's still in the 4-jaw lathe chuck. Okay, so we heated the gear up, slid nicely over the arbor. We're going to let it cool for a few minutes, and hopefully it should be bound there well enough to do some lathe work on it without it spinning. Not quite sure how we're going to get it off yet. I'm going to try and heat it again. As long as the gear expands faster than the arbor it's on, it should come off okay. Okay, just let me bring it back here a minute to see how well this thing bonded to the arbor. Got the pliers on and I'm not able to move it, so it appears it did what I was hoping it to do. So we're gonna machine down probably this surface here. We're gonna machine the face of this, and then we're gonna cut a little, I guess I would call it a counter bore inside, so we can fit our new piece on there. The next step we're gonna do is we're gonna face off the end of this sprocket, and then we're going to come back and machine down the diameter of it. And it doesn't particularly matter what diameter we have it, we just need to match our new spacer accordingly to it. The next step here is to cut the counter bore in the sprocket so we can locate our new inserted piece we're adding on. I'm going to switch out the cutting tool now to put in a boring bar, and then we're going to bore out the inside diameter of the sprocket. We're going to go in about an 1/8 inch deep, and then make it about a 7/8 inch diameter counter bore, and then we're going to fit our new insert inside of that. Now I'm going to touch off on the end of the sprocket, and then we're going to just move over 1/8 of an inch. We're going to touch off on the inside diameter just to get a feel of where it is. And then we're going to bore that out to 7/8 diameter. Here's the dial I use, and I would call it the y-axis on the lathe, but it might be called something different. So we'll speed this up and get to it. The counter bore is now cut in the sprocket, and we need to try and remove it from the arbor. We're going to put some heat back to the sprocket again and try and remove it from the arbor. Well, it went on so easy. I reheated the sprocket one more time while it was in the lathe and still was not able to get it removed. So I took the arbor out of the lathe chuck, brought it over to the vise, and then reheated it again and got a little more aggressive pounding it out, but I did finally succeed with that. I used the same process for putting the counter bores in each of the sprockets, then the same procedure for removing them from the arbor. We're going to speed through the machining steps here needed to make these bushings, simply because it's probably not that interesting to most people. So we have the machining done on both the outside diameter and the inside diameter and the shoulder and our bushing. Now I'm just using the cutoff tool here to cut off each of these spacers. Okay, so we have our little spacer bushing made here, and you can see it has a shoulder on it, and we have this recessed area cut down into the sprocket here, and I hopefully allowed enough material left on here, so when we heat this up, hopefully this will drop in or tap it in, and then it'll expand again. And then that should have our sprocket renewed again, and then we're going to have to come back and drill probably a 3/16 diameter hole about 180 degrees off from where the current one is, and we just maybe fill this in with some kind of a filler. So let's heat this up and see how this works out. I'm going to heat the sprockets up to around 300 degrees. I think that'll be enough to allow it to expand far enough so that our bushings will tap in there without too much trouble and then hold snugly. The spacer bushings have been installed and they seem to fit tightly, so I'm pretty confident they're going to stay in there as intended. Let's switch back over to the bearing hubs. So I had this in the lathe and bored it out, and I created a sleeve, and then I pressed this bronze colored bushing inside of this sleeve. So it's not going to have a roller bearing in right now, but it's going to be I think more than sufficient for a temporary fix to get us by for now. So we have a bushing within the hub, and this was the hub that was cracked out. I considered putting some kind of a JB weld or some kind of a filler in here. That's a pretty significant amount that would need to go in there, so I don't think I'm going to do that at this time, because I'd like to either find another one of these at some point or possibly make another one from scratch. So anyhow, this bushing here did have a through hole in it for grease, and it had grease grooves cut in it. So I had to come back and drill another hole in to meet the hole going through. As you can see by the pointer popping through, that's where the grease is going to go. This hole is a 3/16 diameter. Now the fittings that were in some of these, at least the sprockets here, and it appears at least one of these hubs, were a press type fitting. So I drilled that to 3/16, and this is a little over 3/16 diameter on the end of this grease fitting. So I made a special tool. We're going to stick that there, and then all I did here is I had this piece of round stock. I drilled a 17/64 diameter hole, which is like one size over a 1/4 inch in fraction, and so that's going to go over top this grease zerk and press on that shoulder. So I didn't want to pound it in right off the top of this because that could damage it. So let's press that in and see how that comes out. This was the first time I've ever used one of these press-in type grease fittings. I found them at a discount tool store the other day. So it appears they hold in there quite well. So we're just going to give it a little shot of grease now just to verify that it takes grease. The grease zerk seems to work just fine. So now we're going to move on to the other bearing hubs and see what we may have to do to get all those working as well. So looking over the other 3 hubs, this particular one, it appeared it may have been a 1/4 inch press fit type of fitting. I'm not real sure. It was broken off. Actually, the front 2 were both broken off. So this one, I'm gonna actually drill a hole on the other side because this hole is kind of screwed up, and then we're gonna drill and tap that to a 1/4 inch fine thread, and we're gonna go through and fix the other ones up. We'll probably do that off camera because it's not too interesting. After getting the grease zerks fixed up on all of the bearing hubs, we're going to take the three good hubs where the roller bearings still exist, And I'm going through with a die grinder here with a brass rod in, and have some emery paper attached. And we're just going to kind of clean up and smooth out that hole in there a little bit. We have the bores cleaned up and smoothed out on all three of these bearing housings where the roller bearing fits into. Now we're going to move on to seeing what else needs to be addressed on Brutus. Taking another look at the chassis on Brutus, I see some brackets that are bent. So we're going to take it apart further, and I think it'll be worth the time to straighten those brackets back out again. I don't know if you can see it real well, but this arm here has a bow in it. Again, this one has a bend in it. And I was going to try and straighten that up while it was on here, but I think it might be worthwhile taking it apart. I noticed this arm has a bend in it. The coupling here where it swivels has got a lot of wear in it. I'm not sure what that's going to involve yet. I will probably take that apart, at least if anything else, just take a look at it, see what it's going to involve. This arm across here has a little bit of a bow in it. I don't think it shows up well at all on camera, but that needs some attention. So I've decided it's worthwhile splitting this thing apart some further and straightening out the arms. We're not going to be painting it this year or addressing all the issues it has. When we do get back around to working on it again, we'll have to tear everything apart again. Not a big deal though. Well, that went terribly wrong. I knew in the back of my mind that was probably a bad idea, and turns out I was right. At least we now have a good view of the underside of the machine. The engine is now spilling oil out all over the floor. On the bright side, it needed to be changed anyhow, so I guess we're getting a head start. Looks like it's coming out of the air cleaner tube area. Let's put a catch can underneath there to catch the rest of the oil that is coming out. We'll probably just let it drain overnight. This will be a good time to scrape the grease and debris off the bottom of this engine mount here. Pretty crusty stuff on here. I'll keep picking away at this to get it cleaned up and bring you back when I'm finished. Okay, so we have this mounting plate cleaned up fairly well by scraping it. If I were going to paint it, I would get a hot water power washer in there, but show you a little better view of this brake.
This thing is well worn out. It's probably about half the distance across what it should be. You can see this piece of steel must have been wearing into the drum. There's virtually no, there is no pad left whatsoever other than a few little fragments here. So I don't think I'm going to address that this year for this spring because I got to get it going relatively soon. One thing I wanted to note about this mounting plate, I thought this was a plate of steel with some gussets welded in, but this whole plate is actually cast. I don't know if it's cast iron or cast steel, but it's fairly, appears to be fairly heavy, so I wasn't expecting that. So now let's go over and look at the rest of it here. I still want to tear this down further to address these bent arms, and a little hard to show in camera. If I put a straight edge on it, you can see that, how it's kind of bowed out there. Yeah, there's probably, I don't know, 3/16 of an inch bow, and a little worse right at the end. And this back arm, you can see how that bows out right towards the end. So we're gonna do more disassembling on, take these brackets and arms apart, we're gonna straighten them out. And there's a lot of slop in this middle pin area here. I don't really know what's holding that pin in. I tried tapping it out, and now it's very loose, but it won't come out. So I gotta dig into that. But we'll get that apart, and if I have time, I'm gonna address that too, because that is pretty bad. But if not, we're gonna run it this year. I'm going to continue on disassembling this frame assembly, and we're going to take you through this quickly. We need to get this pin out of here that pivots. I see some other issues going on. I'll explain in a minute. Okay, well, I found a few more interesting things under here. If you look, there's an old spark plug wedged in here and broke off. Now, I don't know any idea what purpose that might serve, and maybe not any purpose. Maybe someone stuffed it down there and got wedged in there. I have no idea. But and another thing now I noticed, a grease fitting down here. It looks like this used to pivot, which would make sense, but it appears to be welded up. So, and also I see a bolt through there. So I don't know if the bolt now just keeps it fixed so it doesn't rotate, and the weld was just to fix something that was broke. So I'll take that bolt out and see if it pivots. If not, I'll have to figure out what to do there. Whether I want to tackle that before I run it this spring or wait till next year. Let me just tap on this a little bit. Okay, so that pin appears it will pop out of there. I don't know, when I was had it flipped up the other way trying to pull it out, it didn't seem to want to move, so we'll knock that out and split this thing in half here. I'm just putting a little lube on the other area where it pivots, just
to see if it pivots when I get this bolt out of here. I don't think it will. I think it is welded solid up, but we'll find out.
Well, that appears to be welded on there permanently. Don't know what I'm going to do about that yet. I would like to fix that at some point, but that's pretty involved. I'm just going to have to... And this whole tube is welded on here, all the way up on these gussets. Of course, these gussets are welded solid all the way across. Ah, boy. That may have to wait till another year. Yeah, it's welded on there. This whole, it's really ugly trying to cut that weld out of there. The actual bushings on the top half here, or on this half, are not terribly bad. It's the bushing area in here that is like crazy bad. I almost wonder if there is a bushing missing in there, or at the very least I could bore this out and put a bushing in all the way through, or top and bottom. That's probably my best bet. Here's another view of the old spark plug. I don't know what the story is on that. So we've got some more thinking to do on what we're going to do. It started out as just simply fixing the chain, and well, you can see what it snowballed into here. So, well, we'll press on. Okay, so at the moment we have the 4 bearing housings ready to be reassembled. This one I think I showed earlier. I had the bushing pressed in, a bushing, and we're not going to do anything with this right now. These other 3, I have the cage bearings out. The bearings actually don't look too bad. Now, the housing down in here, you can't see it real well, but it does have some wear in it. I kind of smoothed it out. For now, we're just going to put it together. If I'm going to really fix these things up nice someday, I'm going to bore this back out and put a sleeve in there. And maybe I can reuse these bearings just to get a nice fit with that sleeve again. But it'll, with new grease in them, and I put new grease fittings in all of them. The old ones were all plugged up. This should help extend the life quite a bit here. Then I have to come back and pop these in. I'll probably put some kind of a Loctite or sleeve sealer on these metal plugs after the bearings are inside. Now going over to here, of course I have these pieces made. I may just throw a little primer on and just lightly hit a little yellow paint. I'm not gonna nicely restore these right now, but mechanically they're good. I have the new bushings. What I need to do yet, and I'll show you in a minute, is I need to press these in here, and then I have to come back. Once they're pressed in, I got to re-drill through here into the bushing for the grease fitting, and then we're gonna press these grease fittings in. These are the press-in type. They're not threaded. I'm going to put a little of this engine assembly lube on these bushings.
to try and tap these just a little bit to get them started before going over to the press. So we're going to go over to the milling machine now, and I'm just going to set this up in the vise, and we're going to drill that hole back through this bushing so we can press in this grease fitting here. I'm just going to locate it off a dowel pin. I'll show you that in a minute. So we have the grease fitting pressed in. I'm going to go ahead and do the other one, and we're going to have to come back and clean this hole up a little bit, possibly see if I can find a reamer to run through there to clean that up, or we're going to have to take a little piece of emery cloth and spin it around there. I did find a 3/4 inch reamer. I'm just going to shoot a little WD-40 in there and run the reamer through the hole to clean up any burrs that happen when drilling the hole. So we have the bushing in the sprocket now, and the grease fitting is in there. I checked it. It does take grease. It's a very nice fit on here. So very happy with the fix on this sprocket here. Well, I have one of the bearing hubs back up in the lathe again. When I was have to insert these caps on the ends covering the bearings. Now this is the one we put the sleeve bearing in. What I didn't realize is after I bored this out to fit this sleeve, there was a recessed area, I guess you call it a counter bore, that was recessed into here so it would fit this cap or this plug. And by the time I bored out for the sleeve, that was totally gone. So now I'm going to have to come back and cut through this hardened bushing and then back through this sleeve and cut the counterbore area back in here. We're just going to speed up the video here, getting through the process of cutting in this recessed area for the cap. The cap now fits in the bearing housing. So I think we're ready to reassemble the hubs with the bearings. Have that new counterbore cut in for these caps. So I'm going to grease up these bearings, and they have to be inserted in there. And then we got to come back, put these caps on. I'll probably put some Loctite or something to seal them in there. But before we do that, I want to mix up some JB Weld. On this one here, this is the one where we put another grease fitting in the other side. We're going to fill this hole in, just so it doesn't collect debris. And then on the sprockets here, we're going to come back and plug a hole with JB Weld as well. And these are not structural issues; they're just really cosmetic to fill that back in again. It's the next day and the JB Weld has dried up, so we're going to go through and put some grease inside these bearing housings, and then put the bearings in all of them and cap them off as well. So we have the caps pressed back onto the bearing housings. I used just some blue Loctite I had. Probably would be better to use like a red Loctite or a sleeve sealer, which I was out of that, so they're pressed in there pretty good. I think the blue Loctite will be fine. I didn't show that on camera because the SD card filled up. So, and anyhow, I think we're ready to go with some of this miscellaneous stuff. Coming over here, I've got to, it doesn't show up well on camera, but this bar here has kind of a bow in it. I need to straighten that out. And the ends of these bars are bent over just a little bit. Both of them are that way, so I've got to take care of that. There was another bar here that was bent. I did straighten that out already off camera. So I think I can get this this bar here in the press, and we're going to try and straighten it that way. This always wants to spring back a little bit. I tried over bending it. Let's see how that works. You know, that's pretty close. I think we're going to leave it at that. Well, let's try and deal with these ends a little bit. So I was able to get the ends of both of these arms straightened out, and they look quite good again, so we're going to run with this. So we've got these arms pretty straight now. If I go over, it's kind of hard to see on the camera, but it's quite straight now, both sides. And measuring it from here to here, it was about 27 and just over a 16th, and I measure the other end to the inside. And yeah, we're about 27 1/16, so I feel pretty good about this. It visually looks quite straight the other way, so we're gonna call that good. I haven't decided what to do here yet, this welded area. It was actually welded on kind of crooked as well. So I'd really like to cut it off, try and press that out and fix it, but I don't know if we'll have enough time for that. So I'm going to ponder on that a little longer. Meanwhile, we're going to probably change oil, air filter, and check the oil in the gearbox, change that, and in the engine as well. So we'll come back to that in a moment. So we need to change the oil in this gearbox and then in the motor. Looking at this gearbox, it's made by Granite State something machine. Looks like it takes 30 weight oil. I'm pretty sure I've checked this, but I haven't used in the past when I've had this thing for over 10 years. Last used it about 5 years ago. So I believe here's a check plug, and then a drain plug there, and then on the motor there's check plug, drain plug. Now most of it drained out, if you've seen earlier in the video where the motor flipped on its side and we drained a lot of it out of the air cleaner tube. Just clean up these plugs a little bit, get some of the debris away from it. I better find a better fitting wrench. Let's take the check plug out first. Well, I believe I do see oil down in there. It's a little below the fill line. They do make special square sockets for these type of plugs. I don't have one in this size. I have one like the next size up. But that would be a better option to remove these plugs in this situation. We'll try a piece of cardboard here. See if we can get this to drain out. Let's go over to the engine now and drain out whatever remaining oil is in there. We probably won't see a lot because we lost a lot of it when it flipped on its side. I wasn't able to get at the drain plug good with this adjustable wrench, so then I remembered I had some, I believe they were 8-point sockets, and which would essentially form a square area. So I came in with that and it got it out easily then. I'm going to let the oil drain out of the engine crankcase and then also drain out of the gearbox. Well, at least maybe drain it overnight or at least a couple of hours to try and get out as much as we can. Let's move on to the air filter now. I would imagine it's probably has some oil in it when it flipped on its side, but let's take a look. So yeah, sure enough, you can see some oil saturated into the foam. We'll take that out and clean it out. But taking a closer look at the foam here, it's really kind of deteriorating. It's almost like dry rot. So I think we're going to have to remove that and replace that filter, at least the foam part of it.
So I took a look at the other motor I had. That had a good air filter in it. Feels stable yet. It should probably be, I believe these are meant to soak in oil. I do have some special oil for that. Let's see if this fits. It's larger diameter, but it does look like it works. Yeah, that should be okay. So we're just gonna close this up temporarily, and then we'll come back and oil down that filter if we determine it's needed. So we let the oil drain out of the gearbox and the engine over the weekend. We're gonna put the plugs back in and refill them with oil.
Now we're going to bolt this bracket back onto the rear drum. We've got to bolt the bearing caps back to the axles to the bracket on either side. I gave both bearings a shot of grease, and I believe this is ready to roll again.
Now we're gonna put some oil on this air filter. I washed it out with hot soapy water, or actually detergent, and let it dry overnight. I'm assuming this needs to be oiled. Most of these foam ones do. I guess I haven't verified that. It's kind of an assumption. If someone knows otherwise, let me know in the comments, please. And I have some Yamalube foam air filter oil we're going to use. So instructions on that. I want you to, it says pour a liberal amount of oil on this filter and work it in, and then squeeze it out. Don't wring it out. And so we're gonna work over top this funnel here, and then when we squeeze it out, hopefully it all should go in there. And it does say whatever's left over you can pour back into the bottle, so that's what we're gonna do.
Okay, we're just going to let that set in there for a bit and then reinstall on the engine. So I had this air filter dripping here, any remaining oil that would come off of it. So we're going to put this back together, stick it back on the engine. And before that, I want to take this chain and just put it in, I got some kind of a solvent here. I don't even remember what it is. It seems like it was some kind of water-based paint thinner or mineral spirits. Not sure if I like it, but let's try it again. I've been soaking a few things in it and it works, but I don't think it's as good as regular mineral spirits. Now let's bring this over to the engine. Now another thing we need to do before starting the engine, this fuel line, I popped it off the carburetor. It's cracked up pretty good and it's pretty stiff, really stiff. So that's going to have to be replaced. I've got to run to the local hardware store to find a replacement for that. And another thing I wanted to mention was the sprocket and this keyway. You can see the keyway's kind of bell-mouthed at the end here, which is not great, but at the moment we're going to have to leave that. I may get a longer key just to carry out further into the good area. So the sprocket, my first thought was, well, this thing, the chain must have been spinning around it. It looks like all the points are wore off. Then I got to looking at it closer, and well, the rest of it really looks quite good, and it looks consistent all the way around. So kind of thought maybe that's the way it was made. And I found a brand. It's a Morse 4016. I looked that up. You can still get this sprocket, well, I believe, and it still is shaped this way. So that's the way this sprocket was made. I did find a new old stock sprocket. I believe it was a US made brand. It wasn't Morse. It was still a 4016, but it was more traditional point. So I have that coming. I got it on eBay for I think about $13. It included shipping. Just waiting for that to come in. It might be a couple of days yet. I'm gonna, well, back up a little bit. There's a little bit of wear on here. You can't really see it probably in the camera, but when you're measuring, especially out towards the end here, it's worn a little bit. And then the sprocket, again, it doesn't really look it, but it does have wear in it too, probably even a little more than on this shaft. So it's not terrible. I've got to bolt this seat back on. Just goes back to here. There's just 2 bolts that hold that on. I usually like to give these bolts a little bit of oil, putting them back together. It just makes them spin together a little nicer. Seat is bolted back on. Now we're going to go grab the front drum and lower that back down to the floor and begin to bolt those brackets on. Well, it's time to start bolting some of these brackets back on. I'm gonna start by putting these on the side here, either side, and then we're gonna probably make sense, I guess, to lift this thing back off and then set it back over top the drum area here, and then we can continue bolting the rest of the brackets on. Before we lower the engine platform assembly over top the front roller, I think I want to mount these front idler sprockets on and show you some customized bolts I made for mounting those sprockets. So the arms for these idler sprockets, they had a bushing, I believe it's a hardened bushing, pressed into the arm bracket, and I don't know what kind of bolt situation arrangement they had. They just had a standard bolt, 3/8 bolt going through the frame of the machine and then through here, and then tightened up. I believe maybe it was a lock nut, but what I ended up doing, I don't know, maybe they had a special shoulder bolt at one time. It was not correct, I believe, when I took it apart, so I thought about it for some time, and I came up with the idea, I put the shoulder bolt from the inside through the frame. So it's going to go on here like so. So the shoulder bolt pivots within this bushing. And then, okay, I took a standard grade 8 bolt like so. I put it in the lathe. I drilled through. I tapped it out to 5/16 of an inch. And it's about a 1/2 inch long bearing area here. So what that's going to do, oh no, the shoulder bolt will go through there. I put another spacer washer here. I put another washer here that goes up against the end of the shoulder bolt. Then this goes into the frame. But these threads did not come out long enough because the frame is fairly thick there. So this is where the special bolt I made screws back in. And that will tighten it down into the frame. So I've made 2 of those, one for each arm. So we'll install these right now. So we have the shoulder bolt here. I put some grease on it already. We're gonna put this through the arm. We're gonna put this washer here on. Actually, I want to put a little dab of grease on that too. And we're gonna put this washer on. That's a little bit smaller diameter. It fits just over that 5/16 threaded area, and that'll press up against the shoulder of this bolt. Now we're going to put it through the frame, and you can see that bolt here doesn't come all the way through. So that's where our special bolt's going to come into play. I'm going to put a lock washer on this. And this will fit through that hole and thread on to the threads of that shoulder bolt. So this takes a Allen type of wrench for the shoulder bolt. We're going to snug it up here. The arm is bolted back on and it pivots nicely around the shoulder bolt. Now we're going to go ahead and bolt the other arm on, just doing it the same way with a shoulder bolt and a special bolt I made for that. So I have both the arms on there now. This one's a little sloppier. This one fits pretty nice. For some reason, this hole going through this frame looks like it's a little crooked, and this whole arm looks like it's sitting on there a little crooked, so I may have to twist that just a little bit. I'm going to come back and try and make some adjustments to that off camera. Try and get that runner a little more true. It's time to hook up the motor and platform, and we're going to bring that over, set it over top the drum, and begin to hook the brackets up for that. While it's a pretty simple machine mechanically, putting it back together with a hoist holding the motor platform up was a little awkward, so it took some finagling to get everything lined up just right and the bolts back in, but overall it did go okay. Now that the brackets are attached to the engine platform, we're going to mount each of the bearing housings back onto the drum and attach them to the brackets that attach to the engine platform. With all the brackets being bolted back onto the engine platform, now we need to reattach the center pivot on Brutus. So I did not do anything to take the slop out of this area. We're going to put it together as it is and it will work okay, but that'll be for a later fix. We are running out of time, so we got to get this thing out in the yard as soon as possible. The new sprocket came in today. And well, it'll fit, it'll work. The only thing I didn't like, it's a little bit narrower, which, you know, I guess will work, but as It's just a little less bearing surface on the shaft, which is kind of an issue that we had. But it does have a little beefier set screws, and probably slide a little further on the shaft, maybe getting into a little bit of the better area. So we're gonna have to run with it for now. And then I had this chain soaking overnight, pulled it out, it cleaned up a fair amount. I did rinse it off in a parts washer. It's just a stream of mineral spirits flowing over it, so it cleaned it up a little further. So we're gonna install the sprocket and the chain, and then maybe tackle the fuel line and possibly try and get it running yet today. Not moving because it's raining out, but we'll try and get it running. Now we gotta attach the new sprocket onto the shaft. I'm inserting the old keyway yet. I think that's gonna work out okay. So I'm trying to get it lined up, and I'm just gonna visually line it up with a large sprocket down below, and then we're going to tighten the set screws and run with that. It seems to fit fairly well. It's time to put the chain back on. We've got to slide it over the top sprocket and feed it through the slots into the frame, and then it's got to get fished through the idler sprockets on those bracket arms, and then around the large sprocket, and then reattach the connection link or the master link. So we have the chain back on. It's weaved through the idler sprockets, but I believe there's supposed to be a spring in there, and there were cotter pins, I think, sticking out where the spring attached to. I've got to go put those back in there again. So with the chain back on, I now have the cotter pins installed with a spring pulling on the two arms for the slack adjusters, and then I kind of see an issue here. This chain runs really close to that bolt and to the side of the drum, so I may end up modifying that bolt some more or putting another bolt back in. Kind of the same situation here. I may have to slide the top sprocket over a little bit as well, but we'll figure out something there. Moving over to the shift linkage, or this lever that goes from forward to reverse, I ended up disassembling the joints with the bolts there, and then applying some grease in there as well. And then this throttle cable, it's not the right one. It's on upside down, and only one bolt holds it in because the other hole doesn't line up. At some point when we do a restoration on that, we'll find a new throttle cable. And going over to the fuel line here, I'm gonna pop that off and then put a new one in. So I had to remove this wiry clamp. It was giving me a little bit of grief getting it off, but we got it off. I took the float bowl off, cleaned that out. It was a little bit dirty. And now I'm gonna look into the tank because I did see some crud in there. So I'm gonna remove that and try and clean that out a little further. We're just removing the gas tank now. Took these straps loose, pulled it off, blowing some air in it. It was mainly just dusty inside. There wasn't really too much rust, although later on I did see the float bowl filling back up with some crud. I mean, not a lot of crud, but there was some. I also put a new gasket into the fuel bowl. The old one was really hard and deteriorating. The new fuel line is put on now and connected both to the carburetor and to the fuel bowl. And I also need to clip the spark plug wire back on. That came off when the motor flipped on its side. So we'll get that on and we're almost ready to start. The last time this machine ran was in the fall of 2020. I had moved some dirt around to mound up a hill, and I was going to plant some new grass and pack it down first.
I'm not sure on this throttle. I don't know what's fast, what's slow. I'm going to put it kind of in between. I'm not even sure what way the choke is. I'm going to go up, assume that's choke. We'll give that a try. Okay, let's just see if she even fires.
Well, this caught me by surprise. This absolutely was not staged. This was the very first pull from running 4 years ago, and it started right up. Actually, the choke was actually off. I thought it was on. So, wow, that surprised me. It's time to take Brutus for a test ride. It's pointed for the door and we're almost ready to go. I'm leaving the chain guard off for now, and then I want to spray some chain lube on it as well.
As we're driving it around, it's got some motorcycle chain lube here, and I want to keep an eye on this area where there's really close clearance between that bolt and the drum. I'm going to probably have to do something about that. But also, I don't want to get too carried away fixing this right now. I did a little more researching. It appears that it would have originally likely had a 5-horse engine on, and as I mentioned earlier in the video, it would have had a gearbox on, and then there was a coupler in between directly linking them two together. And I think the 5-horse probably would have sat a little lower. So, and I don't know, I see there's shims underneath this gearbox. That could be factory maybe. So it's possible I may have to move this around. I may not get too carried away with fixing this right now, but if I find the right motor someday, I'd like to put that on and then probably take care of any other needs that it has. So for now, we're gonna do an initial run here. See if it starts up again. We're just going to buzz it around the lawn a little bit and see how it goes. We're going to try and start it that way. It didn't start first pull like yesterday. Well, let's give it a little choke. Come on. Well, this is something else we're going to have to address, I guess.
We had a really bad problem with moles over the winter time, and just using Brutus to crush some of them down. It's going to take multiple passes to get them. Well, I think the initial test went well. I'm going to put the chain guard back on now, and then we're going to fill these drums, front and rear drums, up with water to add more weight to it. So there are pipe plugs on the front and rear drums. I'm just going to remove those. I usually drain it out in the fall, obviously, so they don't freeze. But we'll take them out, get the hose, fill them up with water, and wrap some Teflon tape on the plugs and put them back in, and we should be ready to roll again with a little extra weight. Now that the drums are filled up with water, let's take another little run. We're just going to start it again here, and definitely going to need to fix that recoil, and that may be the subject of another video. We only made it about 100 feet this time. I got near the edge of the yard and I thought the chain came off, and looking at it a little closer, it looks like the actual master link came apart. So I don't know if I didn't have the link in there good, or maybe it hit that bolt and knocked it out, but I'm going to just see if I can round up a new link and get that back in and see if we can get it back on the lawn. I was able to find another master link for the chain. It appears it probably wasn't clipped in there good in the first place, so after putting the new link in, I've been running around and it's been working well again. Well, it rolled back into the shop under its own power. That's always a good thing. I ran it for about 45 minutes. Still had the chain come off a couple of times, although it was considerably better than it was in the past. I did notice this large sprocket on the side wobbles some, so I'm sure that's contributing to the problem. And where the chain came off, it was in rough conditions and on a little bit of a side hill. So I think that roller's shifting around a little bit as well. That's as much work I'm going to do on it this year. I can carry on and roll what I need to roll, but if I do a restoration on it next year or the following year, I'd like to find the correct motor. From what I can tell, it would have had a 5 horsepower Briggs & Stratton on it with a 6-to-1 gear reduction. So if anyone has one of those or knows of one, the closer to Michigan the better. Please let me know in the comments. I just want to insert one more item here. I know I just said I wasn't going to do any more work on it this year, but that chain popping off, while much better, was still bothering me. So I took a look into it further. I found out this whole frame system would slide back and forth on that drum about 1/8 of an inch. I took both the bearing caps off from the front main drum and put shims in there so it would take that slop out. I don't know how they dealt with it originally from the factory because there were no shims in there. But I also took the sprocket apart, or took the sprocket off and tested it for flatness, and it was actually really flat. So I'm thinking the mounting tabs where it mounts to are off a little bit. But anyhow, I got it back together. And I had no problems with the chain coming off, and I used it over an hour. Then my neighbor borrowed it for probably about 2 hours, and he didn't have any issues with it either. So I think it's safe to say that it's solved for now. If you found something in the video that was useful or that you liked, please leave a thumbs up and subscribe. I greatly appreciate it. It will help out the channel.